Thank you for joining part two. If you've already been watching, you've seen that we've established a problem. We have a sump pump that didn't operate for maybe a year, and we didn't know. We didn't know anything about it. So we've tried to attack that by building our own home automation response using an ESP8266 chip and then integrating it with OpenHAB. We haven't done that yet, but we started building the circuit board that the chip will go onto. So thank you for coming back and watching the next phase. We're going to get right into the next step, which is final QA on the circuit board, and then we have to flash some software to the chip. So stick around. We have another little while to go on prepping that circuit to work, and then don't know if it'll be in this video, but the next place we're going to install it to is my basement because the conditions are a lot nicer down there, and there might be some hiccups that come along the way, probably. So join us and we'll get right into it. All right, there are still some steps required before we can call this project done. One of those is that we need to crimp on some connectors for the siren. And I have found these on Amazon and I like them a lot. Very similar to the connectors that you see. Well, the 3-prong one is something you see with RC, but I found single, double, triple, quadruple, I think all the way up to 6, and I bought them so that I would have whenever I need them, and they come in this little plastic container. So we're gonna nip off 2 of these. Try not to ruin them as we put them back in the box. And then along with them is the tiny crimper. And as you can see, it's got different sizes. We're going to be using this one, the smallest one. And the procedure is pretty easy. I like to leave the handle on for a second. I'm calling this little thing that was part of the reel, the handle. You take and set the wire in there so that the back metal crimpers are on the wire wrapping the insulation, and then this wire here, and it needs to extend past that crimp just a tiny bit. So that's a perfect placement there. Open the crimper, and then I'm gonna have to put on these glasses, hang on. And then there's 2 pieces of crimper in here. There's a line that separates the 2, and I've got the light on it. I don't know if you can see it. Your goal is to set this in here so that the wire crimp is on the left side and the insulation crimp is on the left side of that. Oops, hang on. Gotta make sure those insulation crimps both enter in, and then boom, done. And we did it wrong. How did that go south? Boy, we really messed that up bad. Huh. All right. Well, we got to try again because we got to finish this. So let me try to do it without trying to make sure that it's all visible on the camera. So I'll stay focused on the crimping instead of the display. There. See, that makes a nice crimp on the insulation, and then a decent crimp there. And did it bend the connector a little bit? Oh, I think it did. Boy, I think I failed 2 times in a row here. All right, well, maybe I'll do this off camera because I made a mess of this. So please hold. All right, apparently the secret is don't try to do this on video and everything will be fine. So then I come through and nip off the thing that I was using to hold on to the crimp or the terminal. So then these nip off real nice. It's nice soft metal. Okay, so now we have two ends of the wire, and then there's a little arrow on this. I like to put the hot on that side. So then these just slide in there like so. Nice and easy. And you've got to get them past a certain point or else they won't stay in, and it can be difficult to push them the rest of the way in. Come on. But you want them to be firm in here because they have to expand over the terminals here, the posts. And if they're not held in here really, really well, they'll slide out. So I have a blunt X-Acto blade that has the tip cut off or sheared off. And with the blade pointed away from my finger, I find that it's a decent thing to give a little push. I'll nudge. Okay. And now there is polarity, and I don't know how important the polarity is on this, but what we've done is by having a, oh my gosh, why did I forget the name? A transistor. By having a transistor here, what we've effectively done is we've made a path to ground. And so there's 3 volts coming to this post here, and then there's no path to ground on this post. And so the speaker doesn't make any noise. There we go, we clip it in. And as soon as the voltage comes to the center pin of this transistor, it closes the gate that's in there and allows the ground to flow to ground. And that's how we're using this. And the reason it's here instead of just one of the ports off of this should be obvious. We want to operate without this in place. So, okay, good. We now have that completed. The next step is the software that we'll be putting on this chip. What I'm struggling with now is how do I best serve you, the audience? I have an existing network, an existing ESP home system, and I'm going to adopt this device into that system. It is my goal to someday start from zero with just an empty Raspberry Pi and install a one-time system that's all self and contained. OpenHAB would be on it, MQTT would be on it, ESP Home would be on it, the ability to do some other things would be on it. And I'd like to build that as a tutorial from start to finish soon. But right now I just need to adopt this device into my existing system. So I've got a brand new ESP8266 device, and I feel like that will be the best experience for you guys. I'm also going to do the adoption over Windows, which I don't normally code or do things on Windows. It's kind of a toy operating system for me. Normally I use Linux, and I have a system in my office here where I can flash these devices from Linux really easily. But I feel like that's a big leap for a lot of you. You're running Windows or maybe Mac. So let me do that. Let me start with this device here that's in the sealed box still, and I will show you how to adopt a brand new device into an existing ESP Home system. I won't be at the computer where ESP Home is running. It's actually running on a small array of computers of little Raspberry Pis using Kubernetes. So that's the most you'll get from this video, is me putting brand new code on this device from the perspective of a Windows computer, and then some other time, yeah, I'll build a nice system. To this Windows machine, I have just a standard USB mini. It's the one with the flat connector. It's not USB-C. And these ESP devices, the new ones have started using USB-C, but this one has just a standard USB mini, I think is what you call it, to the Windows computer. I am aware there are screen capturing software that might be best for this, but as far as voice capture, what I've got going on with my phone is the best. As you can see, I've got a bunch of devices. Some of them are projects that aren't done yet, and that's fine. But we're gonna create a new one. So you hit new device using a USB, yep, Yep. Okay, so this last part here, alternately, you can use ESP Home Web to prepare a device for being used with ESP Home using this computer. That means the computer you're currently sitting at. So that's what we're going to do. And this can take a second. Oh, looks like I already have the device, the program installed. So we rip this open. You know, nice placement of the thing that lets you peel. I'm going to leave the foam for all the pins so that we're going to power this up. None of them can be statically charged. We're going to plug it in. I don't know if you saw it, but a little blue light flashed, and then I heard my computer go ding. So let's hit connect. No compatible devices found. This is a compatible device. Let's see. Cancel. Do I have to acknowledge something? Ooh, we might need the driver. I may have never done this from Windows on this machine before, so let's inspect this to see what driver it's using. The CP21, I think it's the CP2102 driver. So here we go. You guys are going to experience with me this live. Let's see. So yes, download software. Universal Windows driver, that looks good. A little pop-up blocker said, are you sure? Download started. So give me just a second to exit full screen. I just don't want you guys to see all my tabs and stuff, so let me install this driver. All right, after a few seconds, that driver has been installed. So now let's click connect. Oh, come on. What if we disconnect it and reconnect it? Let's try that. We're getting blocked down here by saying you don't have. Nothing there. Pretty sure we got the right driver. Do I have to reboot my computer for a driver to kick in? Let's try that. Boy, this is not as smooth as I was hoping, as is my experience with Windows. So give me a second. All right, after a quick reboot, we're back to ESP Home. Let's cross our fingers. We're going to open the web version. I'm going to plug in the ESP device. So it's now plugged in. We're going to hit connect. And oh, still no compatible devices found. That's frustrating. I might have to do the rest of this on a Linux machine. I'll still try to do ESP Web, but I'm not sure why we're getting this. Yeah, not helpful. All right, hang on. Ah, the safety of Linux. I don't know. On Windows, I'm sure there's a way to install that driver and make things work, but this is what we should have seen. We click connect, list of all of the possible ports, and this is the one we want. See that driver name on USB? That's the one. So we're gonna pick up right where we left off, but we're gonna do it on Linux. So we hit connect, and we say prepare for first use. So it's basically going to ask us for credentials for the Wi-Fi. I believe at this phase right here, it's downloading or building the initial image, and then it's going to upload it to that little device. And then from then on, we can use our server system to connect wirelessly to it. So give it just a second. All right. And this is where I'm going to pause and resume. So now it's actually writing some stuff to the ESP device. And then from here, I'll be able to actually visit a website that's running on the device itself. And from there, I'll be able to upload a package, which is running. So Let's see. Oh, darn. Hang on. Okay, attempt number 2. Let's see if I got the password typed in correctly. My goodness, what's going on? Okay, we're gonna try the one that I have prepared for my IoT devices. Hopefully they'll connect to this one. Well, darn it, this is not the path I was hoping this would go. Hang on. Okay, so a couple of cycles. I got a congratulations installed. So we had the right password. Oh, we're back to this again. Okay. Well, this isn't going the way I had hoped. And maybe that's good. Maybe you guys can see that sometimes things don't go as planned. So we're going to try a different method. The web version does seem to be connecting, but I think what we're going to do, since this device is having a hard time connecting to the Wi-Fi, I'm going to use the install feature here. But in order to do that, I first have to have a build. I have to have something to put on it. So we're going to start a new device, brand new. Actually, I think I want to do that empty configuration. Continue. So what are we going to call this device? We're going to call it Sump. Inside. So now here we have this, and it's just the almost empty, and nothing going on. So what I'm going to do is I'm going to grab just a couple of things from here. In fact, you know what? I think we're just going to grab everything from this other one. So that's basically, we're making a clone of the Sump outside. And all we have to do in here is change some names. So that's going to become inside. Friendly name is Sump inside. Location, this is going to be basement. And we'll go down the rest of these and just make sure we don't accidentally have the name outside anywhere, and we shouldn't. Okay, I realize that's a lot of code, and I apologize for going through that so fast, but we're just trying to get this thing flashed. So we'll save that. We'll do an install, and what we're going to do is we're going to download it. So we click that button, and it's going to download and build a whole bunch of C code or C++. I can't remember exactly what it is. And it's going to make a bin file that we can then upload to this little device. So let me skip past this part, and then we'll install it on the device. All right, after a couple of minutes, we're done. And my Chrome will probably say, can't download that, it's a binary file. We just hit keep, and that downloads it. And then back to this one, we say install. We choose the file, Sump inside, and we hit install. On the device, we should hopefully see the blue light flash as soon as it's done. It's erasing it. Now it's installing it. That light you're seeing means it's receiving and acknowledging the data coming to it. And done. All right, very good. Now, when we go back to our actual dashboard, the Sump outside, Sump inside is right here, and in a moment, it'll go from offline to not saying offline, because it's going to be available via its new IP address. We hit visit, and here is the Sump inside all installed and waiting for use. So that is one way. Obviously not the fastest way. The fastest way is if ESP Home is running on the computer that you've connected your device to, you just say connect to the USB and you're done. It's real fast. But this way, you know, is the way I have to do it because my ESP Home is running on a remote server that I can't even pick which USB to put it in. So let's assemble the chip and see if it's working. Before we power it on, I like to put labels on the chips themselves. I know you've seen it on the other ones. And there we go. Now the way we're going to prove that this is actually working is I'm going to trigger one of these floats. Let's see, how am I going to do that? Probably going to have to loosen the wire and let it go open. But first, let's power it up. So we've got our makeshift desktop power supply thing. We make sure we got red going to red. Okay, I saw a little blue light flash, means the thing started. And we're going to loosen one of the pumps. And if this is working, what we'll see is we'll see high on the relay for like 20 seconds. So in order to test that, I certainly could attach a LED to it. I could do a bunch of things. This is going to be the fastest way, is for me to connect the logic probe. So at the moment, it's high. Put this back on. We wait the 20 seconds. There we go. So now we know the software on this device is for sure performing its duty. And when one of the floats goes, it holds the relay open for a little bit longer. Another way we could test this is using the web UI. I can actually turn on, so that should be low. I can actually turn on the pump just using a website. Click a button. There we go. Okay, our software is installed. The system's been adopted into our ESP Home dashboard. And what's next is the glue in OpenHab to start having the rules fire in case some of these open that aren't supposed to. Let's see, what's the other thing we want to test? I want to make sure that there's an alarm when the highest float opens. So we'll disconnect this. There we go, nice and loud. Okay, our wiring job worked. Now we need to mount these in enclosures and deploy them to the sump pumps. All right, we have two of these that we need to do. I found these enclosures a couple of years back. I think I found them on Amazon. I used them for outside garden sensors to just kind of test the soil moisture level. And I had to undeploy them because it didn't work. But I think these make really nice boxes because of the clear door. They lock tight, they're watertight. And then I've got input jackets down here that are also, in theory, watertight. So the one that's going outside should be in good shape. And then they come with an internal piece of plastic that mounts on the sides with screws, and it's offset from the bottom. So you've got room for stuff like this poking through the bottom. So I'm gonna dismount this one. And then something I haven't talked about, let me get in between my power source and the device. I'm going to have this. It takes a size battery and it produces output of either 5 volts or 3 volts, which is nice. I'll use the 3 volt side, obviously. I'll have to solder some pins onto it, but that's not a big deal. It is also uses a oh, that's the wrong type of connector. The USB-C entry point to this is what we're going to use, and I bought a big long cable so that I can run a USB-C cable the whole way. I know we could solder one to some little wires, but I think having a solid cable would be good. Putting a battery here, the one thing I noticed that I don't like about this is that it's not a true power source. It will, if the incoming power turns off, this will flash for a moment with no voltage when it switches between battery and line voltage. And I came up with a way to take both the battery and the output from here, put it into a chip, and use some diodes to always have a steady flow. So it's taking from the battery if this one goes down, but it's taking from this if this one, you know, wherever the power source comes from. I don't think it's necessary. These boot up quickly, and we have all of our backups. We have all of the solid state stuff we did so that we don't have to worry about that. So we'll be mounting this in there, we're mounting this, and we have to be mindful of the input. We need to make sure that the this isn't inaccessible, and that might actually be easiest to mount this on its side like that. I don't know. We'll find the best way, but that's the next thing to do. So let me start fiddling around with placement of this and how best to attach the battery to this so that the thing can remain serviceable, because that's a goal. We want to be able to replace the battery every once in a while. So hang on. All right, nice and mounted. We don't care about the length of those. I'm virtually positive that the length of these little tiny screws are plenty short to still allow for a nice fit in here. Yeah, yep, that mounts nice. So, like I said, we've got cables are going to be coming into this from the pump, and we also have to drill a hole on the side of this, maybe this side over here, for the outlet. We have to have a relay in here somewhere, and then the outlet will be over here that we actually plug the pump into. So we'll need 110 power coming into this, and then there'll be an outlet so that we don't have to cut the cord from the pump that we buy. And then, like I said, power is going to be coming in here as well, and then coming into this device. And I'm not sure what the best plan is, because I know for sure that we want power coming in here, and maybe I've got a USB-C 90-degree angle. Let's see, are there any other ways to get voltage into this? 3 volt on this side. Yeah, there's got to be a way for, there's a lot of little solders in there. We don't want to mess with that. This has less, but I still don't think we want to mess with that. Man, it would be nice if this device had a input solder. Something to think about for the next time that we're buying stuff like this, because then it would be very convenient to just mount this straight here, that'd be nice. Another thing we could do, this won't work outside, but there is a series of LEDs on here that give you the charge percent, and it'd be nice if this was mounted on the door in a way that would allow us to see that when it's closed, so we can see, hey, the battery's fully charged, and that would relieve some of our problems. This wire would have to come over here. I'd have to have enough room for it to flex. And then what if we were to hot glue some stuff, or maybe use some kind of glue where we can put these nylon spacers that I bought. And let me tell you, these nylon ones, they don't fit these little screws. I wanted spacers, and these ended up being tight. Oops, we lost that one. these ended up being really tight. And so I'm confident that with a little bit of heat, we could make these nuts. And then can we find a glue that will permanently mate this with this clear Lexan? There's gotta be a way. You know what? I'm liking that way. No holes. We won't drill any holes in the cover, but we'll mount the battery to the cover. And worst case, it falls apart and, you know, dangles around in here. But these don't get shocked very often. And then that still gives us really excellent access to the battery itself for replacing the battery. So let me work on that for a minute. And then I gotta, you know, like I said, gotta solder some pins in here. Maybe we'll just solder wire for the power. And that way we don't have to have pins that could come undone. So, okay, let's, I think we could input, is that an output? I can't remember if that's an output or not. I think it is for charging your phone. So, okay, give me a few minutes to kind of put stuff together here, and then I'll show you what I come up with. Okay, I think I found the perfect screw. Just had some little machine screws that we bought at Ace Hardware a while back, and their length looks really close. I don't want to have to cut these. I think it's going to be close, and maybe if I put a lock washer on top, it'll make it perfect. And then what I've come up with is, I think hot glue is the best way to do this. I'll put a dollop of hot glue on each one of these and then just let it rest on the inside of the door there, and then I've got my mounting. And I just have to be mindful when I mount it. I want the input USB-C cable, I want this facing upward so that that wire can flex, you know, and we're not crimping, putting tension on anything. So, and then I guess the last thing I need to check is are these higher? Yeah, these are higher than the highest component on that board. So a plan has come together. So I need to do some heating up of the screws so that they'll insert into these nylon washers really nicely. I'll need to use something to hold the nylon washers while I'm screwing them. Let's see how well yeah, that'll do really good. And the only thing I don't like about these screws is the standard head, but we only hopefully have to do this once. So stand by. All right, I decided I had a better surgical tool than the other one. So let's see if I can get a good clean grasp and a click. Yep, so that's in there nice. I've got the, we're gonna use a soldering iron to put some heat into these screws, and which is, I think, a common practice. So I'll hold the screws with the tweezers. We'll heat them up, mostly on the bottom. We'll set it in there, and then I'll try to drive them home with the electric screwdriver. So we'll get the screw off of the tweezers for a second so that it can be heated. Push with the, yeah, don't be tempted to grab that with your fingers. I would just push the screw in, and maybe a little torch would be better for this, but we're gonna try this. Okay, you up there, you right there. And it just flowed right through there. That's weird. Oh my goodness, these threads are small. I set everything up to do this. Didn't need to. All right, change of plan. We're gonna find nuts for these, and we're gonna embed the nut into the little spacer since it's not fitting. So hang on. Nothing ever is perfect. You know what? We might be 3D printing something that will work for us better. So, yeah, shoot. I think. You know, we could just put some super glue in these posts and then slide the nut down into them and let the nut cure. Or sorry, the screw. Let it cure. And then in theory, if we ever need to remove it, it might come out. Seems like the easiest, fastest way to get from right where we are now to ready to glue it with the hot glue. Hot glue would probably work too. If we put some hot glue inside this and then just pressed the screw tight. Now that one has a little resistance to it. Not very much. All right, let me do some farming around. There's got to be a way to do this without spending a ton of time and without boring people. So hang on. All right, I've got some nice thick super glue. I've got these little screws. Let me grab some washers for them. And we're just gonna try this with the super glue. I'll put some super glue on the threads, insert it into the nylon, and hopefully that'll be good. Okay, here we go. Let's take the first one through. That's a good sized dab of super glue. Push it through once and then turn it upside down. Hopefully we'll have less super glue binding the nylon to the board, which is probably going to happen. And then let's see, if we squeeze that for a second, give it a chance to be real nice and tight. And then put a little dab of accelerator on it. There. Okay. 3 more of those, and we'll be ready to hot glue this puppy. So I'm sitting here getting ready to hot glue this to the door and realized before I do I should probably solder on some power, because otherwise I'd have to test that theory of will we be able to undo the screws in the future, and I would kind of prefer not to test things that I don't have to. So let's make ourselves some power. We got the soldering iron on. I don't know how well this wire is a little bit thicker gauge than the last one. If I put solder on it, I don't know if I'm going to be able to squeeze it through the holes here. So let's see if I can fit through these holes without it. And let's see, if I'm going to install this on the door and it's going to be like that, I think we want the one that's going to be closest. And boy, those holes are small. Let's see, I don't think we're going to get this thick of stuff through there. I don't think we are. So we can either drill that out and potentially ruin the solder points. We can push some pins through and then solder these to the pins, or we can use smaller wire. And I think I'd rather just go for smaller wire. So give me a second. All right, I'm going to use the same wire that I used previously. I know it's kind of weird that I'm pulling LED lighting wire apart for the red and the black. I should just have some smaller gauge wire, but I don't at the moment, so this is what I'm doing. And then I'll probably end up throwing some heat shrink on this as well. So let's see, did we decide which one? I think we did. We want to do this one right here. Positive goes in that little tiny hole. Oh yeah, nice fit. Okay, we bring over the soldering iron and the solder. Wrap it around the phone cable. Put on some speckles. And soldering we will go. Okay, give that a minute to really get all of that wire nice and hot. Absorb all the solder, and we have now the grounding wire, or the negative. I guess in this case it's a negative. Nice and easy. Yep, got all of them through there. That's important to check. You don't want to have one wire jumping across. My hot glue gun is hot. I can see some smoke rising from it. It's ready to go. Okay. Because I've just got this weird habit. I'm just going to make sure that these are hold against the board. Yeah, looks good. All right, let's nip these. Okay, and like I said, because I'm just a little bit weird, put some heat shrink on this just to hold it together just a few times. All right, I can smell the hot glue warming up on us. So we're just going to slide those down. I'm going to use a heat gun that I've got on the other side of my room for 1 second. Okay, and just like that, we are ready to glue. So I'm going to put a generous glob. Generous glob. Boy, this stuff's off-gassing more than the solder does. Okay. And let's see. Oh, you know what? We want the USB-C pointing up. Okay, there it goes. Okay, one step closer. We'll let that cool down and then we'll move on. All right, that looks beautiful. Doesn't that look nice? And when it closes, we'll be able to see the status of the lights. So I'll show you that in a second. First, we're gonna solder up these other ends and attach it to our circuit board. And because I'm old, I can't see. Now I have the glasses on. See some threads coming off this, so we touch a little solder. Beautiful. That'll be okay. Get a little bit of flux to flow. There we go. Nice. A little glob of solder on the end never killed anything. Oh, did I just do all of that off camera? That would suck. Sorry, I attached everything up and you can see the battery was probably 3/4 full and it's going to charge all the way to full. But that chip is turned on. It's in there going. So you can see an example of this. I have another one of these over there on the shelf. And that sat overnight with no input power. So I'm relieved and happy with this setup for my power. So there we go. Good little bit for that. All right, while that battery is charging, I'd like to install the reset switch. This is what we'll use if we ever want to force an unexpected reboot of the little chip. So this is clearly designed for an indoor use, but I'm gonna drill a hole in the case and I'm gonna put the switch down here so that I can reach down underneath and push the button to reset it. We're gonna do this kind of out of the way and we can't go too low or else we'll interfere with when we're trying to mount the board. So just a simple hole, steady pressure, and then a mistake at the end where you jam on the trigger. Not a lot of little pieces of plastic, easy to throw away. Let's check the inside. Oh good, this was in there, in the way. Nothing bad happened. Since this is also going inside, I think I'll mount this on the bottom or maybe the top because I'm not worried about it getting wet. So we're back to hot glue. So because we know we're going to be bringing wires from the top down, let's go ahead and drill a hole in the top as well. And we just need it to be big enough for this connector to pass through, and I'll bet you that's not going to be big enough. So let's drill it and we will just deal with it. So I'm going to put it all the way over here. And chances are we're going to have to make it bigger. Okay, let's see if that did it. Oh, that's close. I think we can push this through there. Excellent. All right, hot glue is warming up. Let's see, do you think, should we drill and screw that in? Make sure our wires are long enough before we do anything else. It's going to be a tight fit there. Yeah, it's going to work right there. And I guess while we're here, let's just finish the installation. These are hand tight, and that's good enough. Okay, our hot glue looks like it's getting there. It's not hot enough yet. Let's see. Should we drill little tiny holes, or should we just put a dab of hot glue on there? Yeah, we could probably drill some really tiny holes. Let's do that. Okay, so just right like that. But anyway, while we're waiting for that, we want to mount this guy right in the bottom in a way that allows us to press the button when we want to reset this thing. Big glob right here. And then without burning our fingers off, we want to try to do our best to center that post over the hole so that when we press on it, we're not binding against the side of the case at all. Yep, that's going to be nice and easy. For the outdoor one, I'll still install it on the bottom of the case, but I'm going to use a waterproof enclosure for it, like a little rubber housing for it. That ought to do it. While that cools off, let's heat up one of these screws and pass it through the alarm. I'm still charging it, so I could close this all the way, but I want to charge. Let's see if we sit this up a little bit like that. This to go in that little tiny hole. So I'm going to do something that's probably not very smart. Just going to start off the process by making the hole a little tiny bit bigger and warm. Okay, so at least now we're in the box. Switch over to the drill. Okay, let's see if we can do some threading. Oh yeah. Perfect. Oh, and that's hot. Okay, there's one down. Switch back to the drill bit. Probably should have just hot glued that. That was probably more trouble than it was worth. So we're not being judged for how this stuff looks. Okay, so, ouch, hot glue, still hot. Got the chip, we got the siren, we have the reset. We need to install the line between the reset and there. That's, you know, another chance to use our crimper. All we have left is the relay and then the multiple ways of us turning this thing on. The float, the manual turn it on button, and the other additional floats. So still some work to do on this. Let me make this jumper wire that goes between there and there. I love these, by the way. Best that I've ever owned. Okay, The way to know if that switch is installed in the correct place is to watch the chip. When you press it, it should flash blue. We don't have any power. Oh, there we go. Whoa, now we got 5 volts? Hold on, that's not right. What is going on here? Oh, you guys. I soldered the battery connector to the wrong side of the thing. I soldered it to the 5 volt side. Oh, I gotta unsolder those. Dang it. Wow, this has not been like an example of how to do this. This has been a comedy of errors. Okay, I hope you guys don't mind. I'm gonna do this part off camera. I don't want to punish all of you with having to watch me fiddle with taking this thing off and putting it back on and soldering it. So, sorry. We may have just dodged a great big bullet with this one because the chip appears to still work. 3 volts is coming in. When I hit the reset button, you see a little blue light blink. That means that it's working. The hot glue experiment with these is a complete disaster. The super glue didn't release on any of these. And the one that it did, it still pulled out the piece of this. So I think what we're going to do is we're going to do it again. We're going to make some slight changes to the way we did it. For example, do you remember when I said, hey, why don't we just use super glue? And then I said, no, what if we did hot glue? We're going to try hot glue this time. So a dab of hot glue into this piece of nylon, just a little tiny bit. And then I think we need to be a little bit more urgent than this. We probably should have had this in place. Oops. And then we just kind of squeeze that on there real tight. No, it's not going on now. Oh, you waited too long. I have a pair of real pliers. Okay, we're just gonna crush that on there. There, it's happy. You need a little crush too to get back. All right, and then which way is our USB-C? That direction. So we're going to put you in like so. And I think the difference we're going to do this time is, since I've got 3 spots on there with glue on them already, I'm just going to put a dab here, dab there, and a dab there. There, and now you guys can see that, you know, not everything works on the first try, and sometimes you mess up royally. But I think we came out okay because I'm looking at the web server, and the Wi-Fi signal is still good, negative 67 dBm. That's decent. If I click that on and off, it's responding. I don't think we fried our ESP. I was afraid we might have, and there's $6 down the tube, but we didn't. So thank goodness for that. And I guess I'll just need to pay more attention to stuff like that. So I have one more button to create for this, and I think I'll do that off camera again. But these last little pieces are just driving me. Oh, and by the way, I tested the reset. It works. I think I showed you that already. So yeah, rough day. This has not been going smoothly. You know what? I think I'm going to use this button to control the manual on-off so that you can turn it on and then turn it off. Maybe a push button would be better. And, you know, I do have better push buttons too. So rather than using a keyboard momentary, I can use one of these. And that might be nice to have on, let's see, the top maybe? Because it'll be down on the wall like this. And I can put a label right here that says manual pump. Oh, you know, man, butterfingers today. So let's do that. Let's put this button on the top right there. I'm going to use some of this wire again, but this time I don't care about black and red. And let's see, from the top down to the bottom with a little bit of wiggle room. That's probably good right there. Let me turn the soldering iron back on. And we're not going to fiddle around with connectors this time. We're just going to solder these ends onto the switch and then solder these two ends so that they can be screwed into the connectors. So let me get this stuff out of the way. And let me do that off camera because I think this video is going to be intensely long. I think we should call that the video. This is the end of my tinkering for now. I have to install this circuit board with the chip into my basement sump pump first. And I'm already at the like 55-minute mark on this one. So what I'm hoping to like impart to people who are watching is that you can invent stuff that isn't made, and you can also make mistakes. Soldering isn't permanent. You saw on this clip that I did have to desolder some stuff, and they make tools for that. So, you know, when you buy a soldering iron, a lot of times you'll want some accessories with it, and go ahead and get some solder wick is what they call it. They make desolder pens where you push a little button and it vacuums the solder out. I don't have one of those. Get extra flux. Get the little brass accessory that allows you to clean your soldering iron tip. It's very handy. But you basically, you have free reign. You're inventing. So have fun with it. Make mistakes. I did end up not using the battery holder in that video because it flickered for like 2 seconds between shore power and battery power. And I went online and found some that don't do that. They're always on. So, you know, and then I decided not to use those nylon things. I 3D printed some holders. I still hot glued them to the door, and then it has strands. But you know, experiment, try stuff around. I could have just hot glued that chip to the door, that battery holder. But yeah, man, just create stuff and make mistakes, and ask the internet how to use resistors to you know, tie things to the ground so that, you know, all that stuff. And then the equipment, it's not that expensive. That's the cool thing. They make hundreds and hundreds of little chips you can put in combination with those ESP chips that are really cool. Temperature sensors, distance, switches. I mean, you can monitor anything in your house with little switches. I'll try to do more of that. But anyway, let's call this a video. Thank you for watching. The next one in the home automation series will be me installing it in my basement. Obviously, I filmed this a little while ago, so I can tell you a teaser. I had a problem I did not anticipate, and it took me back to the soldering point. I had to desolder a bunch of stuff. So yeah, I hope you enjoyed it, and I will keep making home automation stuff. But I also, my heart wants to be out in the shop taking apart the tractor. So anyway, thank you again for watching, and please leave in the comments if you want me to explain anything better. I think I'll make a wrap-up video when I'm all the way done, where I will go over the code and how I deploy that. So thanks again, and have a great time.